This lesson is on regression analysis. For any set of paired data, we can draw a scatter diagram, or what we call a scatter plot. For example, if we take this set of paired data, we have the load and the length. The load is 0, the length is 5. The load is 1, the length is 6. The load is 3, the length is 8. The load is 2, the length is 7. The load is 6, the length is 12. For any set of paired data, we can come up with a scatter diagram. To construct a scatter diagram for this data set, we simply draw two sets of axes. A vertical axis, which of course we call y, and a horizontal axis, which we call x. Recall that we said that all the problems that we do in this class, we'll let x be the first variable, so x is the load in this case, and we'll let y be the second variable. X represents the independent variable, y represents the dependent variable. Now, the load we will put on the horizontal axis. The load goes from 0 to 6. So we need to at least go up to 6 on the horizontal axis. Now, when you do your problems, it's up to you to decide what scale you will use on the x and y axes. For my example, for this example, I'm going to count by 1, since I have very small numbers. If you have very large numbers, of course, you will probably have to count by something other than 1. So I'm going to go 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And that will take care of all my numbers that I would have on the x-axis. Now, on the y-axis, I need 12, so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Now I have my axes laid out. The next thing I do, I graph my points, just like you did back in your previous math classes. You look at your points. For the first point, x is 0, y is 5. So you start here at the origin. 0 represents x. That's how far you go across. So if x is 0, you don't go any across. You just stay where you are. Then the second number, y, is how far you go up or down. So you don't go to the right or left because x is 0. You go up 5. 1, 2, 3, 4, 5. And you put a dot. For the next point, you start at the origin. You go 1 to the right because x is 1. And then you go 6 up because y is 6. And you put a point there. So for each pair of numbers, you will have 1 point. For the next point, you go 1, 2, 3 to the right for x, and you go up to 8. You go 3 to the right and up to 8. For the next point, you go 2 to the right and up to 7. And for the last point, you go 6 to the right, and you go up to 12. You go 6 to the right and up to 12. And there you have your scatter diagram. Now, as you can see there, the points that we have do not lie on a straight line. The line is not exactly straight. And from your previous study of mathematics, you learned that we can draw a line through any 2 points, or 2 points determine a straight line. So we can have several different straight lines for this data set. We can have a line going through those 2 points. We can have a line connecting these 2 points. And as you can see, those 2 lines are not the same. Now, what regression analysis is finding the line that best fits this data set. Now, as a mathematician, I can look at this data set and I could say that maybe this is the line of best fit just by eyeballing the data set, by eyeballing the different points. Another mathematician could look at another data set, could look at this same data set rather, could look at these same points, and by eyeballing these points, that mathematician could probably come up with a different line that he or she would consider the line of best fit. Now, you could have, maybe in this case, 4 different mathematicians or statisticians, 4 different lines, if they had to determine the lines just by looking at the points. Of course, they would not have to do that, and we will not have to do that, because mathematicians and statisticians have developed formulas that we can use to find the line of best fit for a data set. Now, before we can use those formulas, we need to review some basic facts of algebra. First of all, recall that any line, any non-vertical line, can be written in the form y equals mx plus b. Any non-vertical line can be written in that form. Also recall that the m that I have here, the number beside x, is called the slope of the line. And of course, the slope tells us how much a line is slanted. The b represents the y-intercept. Now, if I give you the numbers for m and b, the numbers for the slope and the y-intercept, then you can write the equation of the line. For example, if I tell you that I have an equation and that m equals 3.7 and b equals negative 0.072, you can tell me the equation of the line. The equation of the line would be y equals 3.7 x plus a negative 0.072. That's the equation. of the line. That's the equation of the line, whether it's a regression line or any other type of line. If I tell you what the slope is and the y-intercept, you can give me the equation of the line. Essentially, what you do, you take the number that I give you for the slope. I said the slope m equals 3.7. You take that number, you erase m in the equation y equals mx plus b, and you write that number, 3.7. If I tell you that the y-intercept b equals negative 0.072, you erase the b in this general equation, y equals mx plus b, and you replace it with the negative 0.072. And thus you have the equation of the line. So all you need to do is come up with the numbers for m and b. And then you can write the equation of the line. Now what mathematicians and statisticians have done, they have given us formulas for finding m and b. And all we have to do is use these formulas, substitute the numbers into the formulas, and use our calculators to figure out or to simplify the expressions we get when we substitute the numbers into the formulas, and that will give us the numbers for m and b. So let's take a look at the formulas that statisticians and mathematicians have given us for finding m and b. And then we'll look at an example so that we can see exactly how these formulas work. The formula for m, the slope of the line of best fit, is n times the summation of xy minus the summation of x times the summation of y over n times the summation of x squared minus the summation of x to the quantity squared. This is the formula for the slope of the line of best fit, the regression line. That's what it is. The formula for the regression line. The formula for the slope of the regression line. For the y-intercept of the regression line, the formula is the summation of y times the summation of x squared minus the summation of x times the summation of xy over n times the summation of x squared minus the summation of x with quantity squared. This is the formula for the y-intercept of the line of best fit for a data set, what we call the regression line. Regression analysis is coming up with the equation of the line of best fit. Now, let's look at the data set that we had on the board previously. We had the data set, we had the load, and we had the length. And let's start a vertical table. We would use x in the first column, y in the second column. And we'll write our numbers. And we'll develop our table, as we go along, based on what we need in the formulas. We have x and y. We were talking about the load and the length. If the load was 0, the length was 1. If the load was, the length was 5. If the load was 0, the length was 5. If we had a load of 1, we had a length of 6. For a load of 3, we had a length of 8. For a load of 2, we had a length of 7, and finally, for a load of 6, we had a length of 12. So those were the numbers in our data set. We had 1, 2, 3, 4, 5 pairs of numbers. Now, we look at what we need in the formula for the slope. The slope equals n. We know what n is, the number of pairs. We have 1, 2, 3, 4, 5 pairs. So that means that we can erase the n in the formula, and we can put a 5 there. Next, we have the summation of x times y. This means that first of all, we have to multiply the x times the y. And then we have to sum those products. So we look at the table that we have here. We know we have to multiply the x times the y first, so that means we have to add another column. We call it the x times y column. And we proceed to multiply x times y. 0 times 5, we get 0. 1 times 6, we get 6. 3 times 8, we get 24. 2 times 7, we get 14. 6 times 12, we get 72. And then we have to add those together. We add them together, and we get, for the answer, 116. 116. And the 116 represents the summation of x times y. So the summation of x times y equals 116. The summation of x times y equals 116. So that means that we can erase the summation of x times y here, and we can put 116. Next, we look at the formula. We have the summation of x. That simply means that we have to add the x's together. So we add the x's in this column, and we get 12. So we have the summation of x equals 12. So that means that we can erase the summation of x here, and we can put the number 12. Next, we have the summation of y. That means that we have to add the y's together. So we go to the y column, we add the y's together, we get 38. So that tells us that the summation of y equals 38. The summation of y equals 38. So now, in the formula, we can erase the summation of y, and we can replace it with 38. Now, in the denominator, we need n. We know that n is 5. We need the summation of x squared. Next, we look at the table, the summation of x squared. That tells us that we have to square the x's first, then we have to add or sum those squares. So we look at the table, we know we have to square the x's first. We haven't squared the x's already, so we add another column. We call it the x squared column. And we proceed to square the x's. The first x is 0. 0 squared is 0. Next x is 1. 1 squared is 1. 3 squared is 9. 2 squared is 4. 6 squared is 36. And of course, the summation sign tells us that we have to sum or add those squares together. We add those squares together, and we get 50. The 50 represents the summation of x squared. Summation of x squared is 50. The summation of x was equal to 12. Now, that means that we can erase the summation of x squared in the formula, and we can put 50. The next thing we have here is the summation of x, the quantity squared. Now the summation of x we found before. We added the x's together, we got 12. So we can erase the summation of x here, and we can put the number 12. So thus we have found all the numbers we need to find the slope of the regression line, the line of best fit of the data set. So we take out the calculator and we do the calculations that we have there. Of course, we have to keep in mind the order of operations that we had in our previous math classes. We have to keep that in mind as we do the calculations on this problem. So take out your calculators at this time and see what you come up with on this problem. Now, the number that you should have gotten for m is 1.17. That represents the slope of the line of best fit. So we'll write on the side here, m equals 1.17. Now, before we can write the regression line, the line of best fit, and complete our regression analysis, we need to find the y-intercept of the line of best fit. Once again, this is the formula for the y-intercept of the regression line. The formula is v equals the summation of y times the summation of x squared minus the summation of x times the summation of x times y over n times the summation of x squared minus the summation of x to quantity squared. Now we look at the formula and we look at our table, and we see what numbers we need in the table in order to complete the formula. We start with the first term in the formula, or first factor in the formula, and that is the summation of y. That we already have. We have already summed the y's, and we have it over here. The summation of y we found was 38. This means that we can substitute for the summation of y the number 38. Next we have the summation of x squared. Once again, we've already found that. All we have to do is look over here. We have the summation of x squared. We found out that that was equal to 50. So all we have to do is just substitute the 50 in there for the summation of x squared. Next we have the summation of x. We already have that. We found that the summation of x was equal to 12. We can substitute the 12 in the formula for the summation of x. Next we have the summation of x times y. The summation of x times y we found was 116. So all we have to do is substitute 116 in the formula instead of the summation of x times y. Next we look at the denominator. In the denominator, the first thing we see here is n, the number of pairs. We had a total of 5 pairs of numbers. The next factor is the summation of x squared. Once again, the summation of x squared is 50. We can erase the summation of x squared, and we can substitute a 50 in its place. Next, we have the summation of x, the quantity squared. We already have the summation of x. The summation of x, we said, was 12, so we can just substitute a 12 there instead of the summation of x. And thus we have all the numbers we need to find the y-intercept of the regression line, the line of best fit. Now, at this time, I want you to take out your calculators, and I want you to complete computing the value that we have there for B. In fact, after you finish that, see if you can write the equation of the regression line. See if you can complete this regression analysis. Now, the number that you should have gotten for B is 4.97. That's the y-intercept. That's where the line of best fit crosses the y-axis. Now we have all that we need to write the regression line and complete our regression analysis. Once again, remember that regression analysis is finding the equation of the line of best fit. And once we get that equation of the line of best fit, that completes the regression analysis. Remember that the equation of any line, any non-vertical line, is y equals mx plus b. Now we know that m equals 1.17, or 1 in 1700ths. So we simply erase the m, and in its place we put 1.17. 1.17. We know that b, the y-intercept, is 4.97. So we erase the b, and we put in its place 4.97. This is the regression line. This is the equation of the regression line, the line of best fit. Now, one thing that's very powerful about the regression line equation is that we can use that equation to make predictions. For example, in the problem that we did involving the load and the length, the load that we put on the spring and the length of it, we didn't put a load on the spring that was 25 pounds, for example. We didn't put that load on the spring. But based on this line of best fit that we have here, this regression line equation, we can predict, using this equation, what the length of the spring would be if we put a weight of 25 pounds on the spring. We can make that prediction based on the regression equation. So this is one of the powerful ideas behind the regression equation, being able to use it to make predictions. We can predict things that would happen in the future by using a regression equation. For example, if we wanted to know the length of the spring, if we wanted to know the length of the spring, if we put a load of 25 pounds if we put a load of 25 pounds on it, we want to know the length of the spring. So to do this, recall that the load represents x. We're saying that x equals 25. So we take the regression equation, y equals 1.17x plus 4.97. We're saying that x is 25, so instead of the x here, we substitute in parentheses 25 for x. We substitute 25 for x. And then we take our calculators and we do the arithmetic that's involved here. We multiply 1.7, that's 1.17. We multiply 1.17 times 25. That gives us 29.25. We add that to the 4.97. And that gives us 34.22. 34.22. This tells us that if we were to, sometime in the future, put a weight of 25 pounds on the spring, the length of the spring would be 34.22 inches. Now, to recap what we are doing in regression analysis. Once again, in regression analysis, you have to find the equation of the line of best fit of the data set. That's what we call the regression line. To find that equation of the line of best fit, you have to use the formulas that we mentioned to find the value for M and the value for B. After you find those values, those numbers, the number for M and the number for B using the formulas, you substitute the numbers in the equation y equals mx plus b. And after you substitute those numbers in there, you have the equation of the line of best fit, and thus you have completed your regression analysis.